Hi, this is Chandra Sripada from the Methods Core team. This is a Methods Core tutorial video, and what we're talking about is building and extracting ROIs. This is really one of the most common things that we do. We specify ROIs, whether they be spheres or images. We extract activations from those ROIs. We store the results. We look at the results in programs such as Excel and SPSS. Well, Methods Core has built an integrated suite to make these operations easy and can be performed rapidly and without errors. So to get started, go to your Methods Core folder, and this is what my Methods Core folder looks like. Yours may look slightly different. Once you've got that folder, go ahead and click on the ROIScripts folder, and then open up. You'll see the template as well as the central script for extract ROI. As always, you hit the template and you make your modifications in the template. You don't make changes in the central script. Now I go over here and I take a look at my my template, and what you'll see is kind of familiar things that you should know from before. You set your experiment folder over here. When you collect all your ROIs, which are specified down here, the output will go to a CSV file. You say where you want the name of that CSV file right here, and where you want that CSV file to reside by specifying the output path template. The next thing that you do is that you specify your extraction jobs. And the key idea here is that the way that you specify an ROI extraction is you want to tell the extractor where your spm.mat file is and also what ROI you want to use. Why do you need an spm.mat file, you might ask? Well, to be clear, this is a second level spm.mat. When you specify a second level spm.mat, you point to the first levels where your subjects and images reside, and all of those are stored in your spm.mat file. By specifying that spm.mat file, the extractor knows exactly what first level subjects and images to go to in order to do the extraction. The next thing I specify is the ROI, and there's two options here, and there's plenty of help right here if you are unsure of what these options are. So what I'm saying here is go to this spm.mat, which is residing in the NetData4 OXT, in particular the OXT Healthy Control folder. And I'm saying extract form of spherical ROI, and we can only do spheres at the current time. Later on we'll add functionality for boxes or other kinds of standardized shapes. And at M&I coordinates -10, 42, 24, and with radius 5, extract from that ROI, applying it to all the subjects and images found in this spm.mat. Another usage is go to this spm.mat, which in this case is the identical one to that one, and extract from an image. And here I specify the full path of the image. And in this case, it's the AAL anatomical image for the left anterior cingulate. I've also specified two more ROI jobs. Now I'm looking at the oxytocin social phobics, and I'm doing the very same ROIs. While I'm at it, I want to point out quickly an advanced function. When the extracting tool has the relevant spm.mat as well as an ROI, there's a further question. What function of the activations within that ROI should be used? A common one is using the mean. Just average the activations of all the voxels found within that ROI. Actually, SPM8 does something else. It uses the first principal component, also known as the first eigenvariate. Because SPM uses the first eigenvariate, we use the first eigenvariate as our default, but you can edit that in this advanced section right here. When I run this script, what I'll find is that in the CSV file that I've specified, I'm going to get columns of output, where each column represents the beta for each of my subjects located in this spm.mat. And I'll get 4 columns representing the 4 extraction jobs that I've specified. So let me go ahead and run this script. And let me just get rid of that output over here so it's easier to see the new stuff that we've done. So I run this script. It tells me that it's busy, so it's thinking and it's working. And it tells you in the screen output, it tells you about each of the jobs it's doing. Let's look at that really quickly. It says, I will extract from this spm.mat, I will use a spherical ROI, located these M&I coordinates with that radius, and I'm going to be using this summary function. And with the extracting program automatically, it also does this for all the other jobs that are listed here. So right now, if I go to this folder, I should be able to see my output. And in fact, I have that folder right here, and here is that file, oxtmpfc test, and this is what the output looks like. So some things I want to point out. There is a header column over here that says each of the ROIs that I've used. So look at this one right here. It says the spm.mat is located here. The ROI is a sphere. Here it's M&I coordinates. It's radius 5, and the summary type is eigen 1. The header column over here lists the subjects and images that were found in that spm.mat. If you'll recall, the first S2 spm.mats that I used were exactly the same. These two right here. So notice that the output file has intelligently, not redundantly printed both spm.mat, the contents of both spm.mats. It lists just one, as well as the betas for each subject, for the subjects and images that it found in this spm.mat. When I went to a different spm.mat over here, here's where I started using the social phobics, right here and here. It then reprints the contents of that spm.mat, and notice this one has more subjects and more images than the first one, as well as the two columns of betas that it extracted. The first one being the spherical ROI that I specified, and the second one being the left anterior cingulate that I specified. So that's all your output. Some things to also notice about this script. There's no need to specify a reference file. The script intelligently identifies the orientation of the ROI that you specify, so you don't need to specify a reference file that sometimes is required to get the orientation information. Another thing is the script itself, as well as the output, contains all the logging information that you need. In other words, from this output file, I know exactly what spm.mat I used. In particular, I know exactly what are the images found from that spm.mat, as well as which spm.mat was used. And I know exactly which ROI I had specified, as well as the type of the summary function. So all the information that you would ever want to log is right there in the output file. We hope that this ROI extraction tool will be useful for you. In addition to this video, there's also text documentation that's going to be available in the Methods Core Help folder. And, as always, if you have any questions, you can always email us at methodscorehelp@umich.edu. A lot of times we get back to you within a few minutes. Thank you very much.